Hi everyone. In this video, we're going to talk about combining argument types so that we get a longer, multi-layered logical argument. Now, hopefully you already practiced some in example 5 on your own to check if you can figure out if arguments are valid or not. So let's look at this long example in example 6. It says all natural numbers are whole numbers, which we can translate as if it's a natural number, then it's a whole number. Then it says all whole numbers are integers, so if it's a whole number, then it's an integer. All integers are rational numbers, so I arrow R. And then it says X is a natural number, and we don't put X, we just put is a natural number, or N. And therefore, X is rational. We put R. So the question is this argument valid or not? If you skip down to the bottom of the page, you can see it says, yes, it is. It's valid by transitivity. But how? So let's look at this. N is going to W, and then here W is going to I. So it keeps going. N to W to I, and then I to R. So this is a long chain that goes from N to R. That means if N happens, R is a valid logical conclusion. And one of the things I like to do when I'm trying to figure out if something's valid or not is to rewrite it like this so that I can see the chain is actually connecting and that the order of the conditional is being followed. Now, if I switched any of these, like for instance, if I put I to W, then it wouldn't work. So it has to go from W, N to W, and then W to I to make that chain. If it went from N to W and then I to W, then W would not be, would not be connected all the way to I. All right, let's look at another one of these. Oh, and also you can kind of tell from the picture, just as a reminder, that here's X. It's a natural number, then it's got to also be inside rationals because all of these are inside this larger circle that's around them. All right, so example 7. Let's take a look at 3 different arguments and see if we can tell which of them is valid and which is not. So let's look at argument 1. But we're going to be kind of strategic about how we look at this. We see that I have A here, and this conclusion is R. So we want to try to find in here a connection that goes from A to R. So I see A goes to B, but I don't see B going to anything else here. It just goes A to B. I do see P goes to Q, and then Q goes to R. But I don't see A going to R, so this is not a valid argument. All right, let's try this one. We want to, again, be kind of strategic. See the X at the bottom? We want an argument that goes from X to M and has M as its conclusion. So let's see. X goes to not Y, and not Y goes to Q. That works. And then Q goes to M. So it makes one long chain all the way from X to M. And therefore this one is valid. Now again, we're going to look for argument 3. We want something that connects not Z to R. And I don't have any not Z's in here. So I'm going to remember that the contrapositive would give me a not Z right here. If I reverse the order of this with nots, I get an equivalent statement. So instead of M arrow Z, consider if I wrote not Z arrow, not M. Would that make a chain from not Z to R? So think about that for a minute. And remember how I wrote notes on the last one? I would write notes on this one. So next to M arrow Z, write the contrapositive version of it and see if you can make a chain. Pause the video and see if it works. Okay, so now let's scroll down and see what it says. So argument 1 is not valid. Argument 2 is valid, and I wrote down the chain in my notes that it gave us. And then argument 3, we had to rewrite. And if you look at it, yeah, it works because when we rewrite it, we have this chain from not Z to R. Not C happens, therefore R. So it's a valid argument. So this concludes our videos for section 3.6. Bye.